Okay, today we are going to create graphs of polynomials given a description. So we're going to sketch a polynomial with the given characteristics, and we're going to try to come up and see if we can come up with multiple ways to sketch the graph. We might have more than two, we might have fewer than two ways, but we're going to see as many ways as we can come up with. Some of them might not work. All right, so we need a third degree polynomial with a negative leading coefficient and one unique root. So here, one unique real root here is going to mean x-intercept. So one unique x-intercept. Now, third degree, we need to remember all of our characteristics. Third degree is odd, and odd degree polynomials have arrows that point in opposite directions. So one arrow is going to point up and one arrow is going to point down. If I have a negative leading coefficient, that means when my arrows point in opposite directions, it's going to have a negative trend, which on our graph means that your arrow is going to start high and end low, right? So we need to have that negative trend. We can curve in the middle. And we have one x-intercept. So there are a couple ways we can draw this. We start with an arrow up high and an arrow down low. If I just have one root, well, I could draw just a third degree function like this. We're crossing the axis one time. That is a third degree polynomial. We can also draw a third degree polynomial that looks slightly different, but would curve like this. Right? So there are two examples of a third degree polynomial with a negative leading coefficient. Next, we have a fourth degree polynomial, positive leading coefficient, and two unique real roots, so two unique x-intercepts. Fourth degree means that you have an even degree, so the arrows are going to point in the same direction, and because it's a positive leading coefficient, you're going to have two arrows that are pointing up. So your arrows on either side are going to start and end pointing up. Fourth degree means that you can have a max of 3 turning points. Okay, so we need a maximum of 3 turning points, both arrows pointing up, and two unique x-intercepts. So here's one example we could do. We could come down, turn, there's 3 turns, come back through. There's 2 x-intercepts, 3 turns. Another way we could do this graph might be to come down through the axis, back up through the axis, turn, and back up again. So that would be another one. There's actually a few more, so let's come up with a couple other possibilities. If we start up high, what if we come down and touch the axis, come down and touch the axis again? I think there's another one. Or we could do our fourth degree polynomial. Remember in our investigation, back in investigation 1, we said there is a fourth degree polynomial that comes down and looks like a wide parabola and comes back up. That's also fourth degree. Okay. There are some variations on those, but I think those are most of the ideas of how the shape of the polynomial could be for number 2. Number 3, fifth degree polynomial, negative leading coefficient, and 2 unique real roots. All right, so fifth degree, 5 is odd, which means that our arrows are going to point in opposite directions. Negative leading coefficient means my arrows are going to have a negative trend. So just like the first graph, we start high and end low. And 2 unique real roots. Because it's fifth degree, we can have a maximum of 5 turning points. So if I start high here, what if I come down? That's 1 crossing, 1 turn, 2 turns, 3 touch, and back down. I think that would work. There's 1, 2, 3, 4 turns, great, and 2 different x-intercepts. All right, we could also try something, let's see. What if I came down and touched the axis here, went back up, 2 turns, 3 turns, 4 turns, and back down. So very similar to that last graph, but we also still have 2 x-intercepts. Now, there are, obviously other possibilities here. You could come down, cut through, come up and touch, squiggle, squiggle down below. So that still has 4 turns and 2 x-intercepts. We're just having our root touch in a different spot. So any variation that would look something like that. All right, graph 4. 4th degree polynomial, negative leading coefficient, and 3 roots. So 4th degree is even. Even with a negative leading coefficient means both arrows point down. So when you make your graph, you're going to start and end down. 3 unique real roots, so 3 different x-intercepts. 4th degree is going to have a maximum of 3 turning points. All right, so if I start down, I need 3 roots. So I'm going to come up, I'm going to cut through this time, come down. I need 1 more root, so I'm going to come up and touch and end going down. I could do pretty much the same thing, just going the other way. So I could come up and touch here, down, cross through, and back. So that's still 3 roots. I think there is one other way I could come up with here. If I start low, I could come up through, come down and touch, back up, and down again. So that looks like I still have 3 turns and 3 x-intercepts. All right, number 5, 6th degree, positive leading coefficient, 0 unique real roots, so no x-intercepts. 6th degree, 6 is even, positive leading coefficient means both arrows are going to point up. And 6th degree means that you could have a maximum of 5 turning points. So if both arrows go up, I'm going to just turn. I'm never going to cross the axis, but I'm going to come down and do 1 turn, 2, 3, 4, and 5. That would be your polynomial. And we could do, let's see, hold on, let me pull up the calculator here for just a second. All right, I'm going to graph just the basic parent function x to the 6th and see what it looks like here. Oh, it is similar to x to the 4th. So if I graph something like x to the 6th plus 5, you see that it looks like x to the 4th, and it's a parabola with a wider base, but it's up above. So that could be the second way that we draw our picture here, right? So you could come down, really wide bottom, go back up. That's another way to draw x to the 6th with no x-intercepts. All right, number 3, 3rd degree, positive leading coefficient, 0 unique roots. 3 is odd, which means that you're going to have arrows in opposite directions. Positive leading coefficient means they have a positive trend. So it means you're going to start low and end high. Now, 3rd degree means that you can have a maximum of 2 turning points and no x-intercepts. So let's think about this. If I start low down here and I need to end up here, is there any way to get between those 2 arrows without crossing the x-intercept? There's actually not. This doesn't work. This actually is not possible because odd degree functions, since they have arrows going in opposite directions, their end behavior is opposite, they must cross the x-axis. Right? So odd degree functions must cross the x-axis. So that means they have to have at least 1 real root, which is not possible for this one with 0. All right, 2 more. 2nd degree, positive leading coefficient, 1 unique real root. 2nd degree, 2 is even. Positive leading coefficient means both arrows point up. 2nd degree means you have a maximum of 1 turning point. This is a quadratic, so a parabola, and 1 unique real root. Well, if I have positive leading coefficient, I start and end up high. And really the only way to graph this one is to come down and touch the axis for my 1 real root and end up high. I don't have a second choice this time other than just moving where the vertex is. Finally, 1st degree polynomial, negative leading coefficient, 0 unique roots. So 1st degree, 1 is odd. Negative leading coefficient means that my arrows are going to go in opposite directions with a negative trend. And no unique real roots means no x-intercept. Well, first degree is a linear function, and those have 0 turning points. Well, just like number 6 up above, if I start up high and end low, I have to cross the axis in order to get from one end to the other. So there is not a possibility of having a linear function here with 0 unique roots with a negative leading coefficient. So same reasoning as number 6. All right, go ahead and try to practice this on the back. You're just, first of all, reviewing and behavior and degree, the relationship there, and then probably sketching some graphs.